In this video we're going to look at straight lines and the general equation of a straight line. A line has two basic properties. One is how steep it is, and the other is where it crosses the axes. If you like, the position of the line and the direction of the line. If we change the slope, then the line, if we change changing the slope obviously affects the tilt of the line. Not only can we change the slope, but we can also change where the line sits on the grid. And we can see that here the slope is the same, but what's happening is that it's moving up the y-axis, or indeed down the y-axis. These two conditions, the slope and the position, define the line. If we know these, then we know everything we need to know about the line. An equation of a straight line generally has the form y equals mx plus b. The number with the x, here categorized by the coefficient m, signifies the slope of the line, and the number by itself, categorized by b, is the y-intercept, where the line crosses the y-axis. If we know these two things, we know everything there is to know about the line, and this format is generally called the slope-intercept form because it tells us information about the slope and the intercept. Okay, let's see if we can figure out the slope and the intercept of these lines. Remember that y equals mx plus b tells us the slope and the intercept. The term in x in the first one is 3, so the slope for this one is 3, and the intercept is minus 7. In the second one we have minus 3/4 x plus 5, so the term in x is minus 3/4, and the y-intercept is 5. Don't be fooled and just think it's the first number. The term with the x is this negative 5x, and the number by itself is the 4. So in this example, the slope is negative 5 and the y-intercept is 4. And similarly, in this last one, the slope is 2 and the y-intercept is 13. Of course, the y-intercept is obvious. It tells us where the line cuts the y-axis. But what does the slope actually mean? Well, the slope is how fast the line is rising, the rate at which the line is increasing. So if we consider where it crosses the y-axis here, if we go 1 unit across, it takes us 2 units up. If we go 1 unit across, it takes us 2 units up. Equally, obviously, if we go 2 units across, it goes 4 units up. The line is rising twice as fast as it's going across, so the slope here is indeed 2. This second example is a little more complicated. The first thing to notice is that it's heading downhill. If I go right on the x, I go down in the y. So this is a negative slope. Well, how quickly is it going downhill? And if we look at any particular one square, it's actually a bit difficult to figure out. So we might need to not just rely on units of 1, but see if we can find any better progression. And if we try to find nice points where it cuts the grid lines exactly, we'll see slightly more easily that if I go 3 units across, I go 1 unit down. 3 units across, 1 unit down. So it takes 3 units across to go 1 unit down, therefore its slope is minus, because it's going downhill, and then 1/3. It's going downhill 1/3 as fast as it's going across. If we go 6 units across, we go 2 units down, 1/3 of how far across. A good way to get used to this is to actually find nice places on the grid where they do intersect the coordinate grid precisely and work it out from there. So here we see that there's another intersection here and another intersection here. So to get from this point to this point, we actually go 2 units across to go 3 units up. We go 2 units across to go 3 units up. So it goes up 3 units for 2 across, in other words 1.5 times as fast, so the slope is 3/2 or 1.5. So the proper formula for calculating the slope is often called rise over run, or how far you increase in the y's over the same increase in the x's, or generally difference in the y coordinates divided by difference in the x coordinates. So we need to find 2 convenient points which we can get the coordinates for, and there is an obvious exact intersection, and that is at the point 2, 1. And we have another one up here, top corner. Look at the scale, that's 5, 6, 4. So how far across do we go, and how far up do we go? And we can see that the rise is 3 and the across is 4, so the slope is 3/4, which is 0.75, and clearly it's positive because the line is going up. This is the same line, and I just want to demonstrate that it doesn't really matter how far apart the points are or where they are, provided you can find exact intersections. So there's also another intersection over here at -2, -2, and let's suppose we use the original point we had just now, 6, 4. So again, we go all this way across, which is from -2 to 6, so that's 8 units, and all this way up, which is from -2 to 4, which is 6 units, and of course the slope is indeed rise over run, which is exactly the same as we had before, 3/4. Also, we can take corresponding coordinates. So if we make the left hand point x1, y1, and the right hand point x2, y2, then the slope was y2 minus y1 divided by x2 minus x1, which was, our y2 was 4 and our y1 was -2, so 4 subtract -2, and similarly 6 subtract -2 for the x's, which is of course 6/8 as we had before. So to calculate the slope, all we need to do is find 2 coordinates that we are sure of, and that's usually where they intersect the grid precisely.